Hey guys, here's the video for Wednesday. So it's the second day of 6.3. We're just going to do a few examples today. Yesterday we rotated regions about the x-axis or a horizontal axis of rotation. So today we're going to do the same thing, except for we're going to rotate around the y-axis, around a vertical axis of rotation. So these examples will be the ones like I described as a carousel. Picture anything that is a vertical pole with something spinning around it. I don't know if any of you ever played that game Tetherball. So you have the pole with the ball on the rope that you would hit back and forth at each other. That would be something similar. A pottery wheel is another thing that I imagine when I'm thinking about these types of problems where you're spinning a bowl or something like that. But it is a vertical axis of rotation, and therefore we have a horizontal slice. Our radius is running as an x equals instead of as a y equals. Okay, so for our first example, rotate the region bounded by y is equal to x cubed y is equal to 8 about the y-axis. So our axis of rotation, I'll color that in green, is right here. The region that is bounded between the two curves and the axis of rotation is there in green highlighted. So just like the first lesson, we're going to do a two-dimensional reflection first, just of the region that we are actually rotating. I'm not going to reflect the entire graph. So we're basically looking at a parabola, but remember that this parabola is rotating everywhere. So it's creating these circles of different size depending upon where we are along the curve. Okay? So the most important thing that you do when you draw this cross section, it's always a circle just like the last one because it's a rotation. So the area of a cross section is always going to be pi r squared. Okay? This is a disk problem. It's solid. There was no empty shaded space as we rotated this. The key here is that our radius is running horizontally. So our r is an x equals. So if there was one misconception in the last section in 6.2 is that we weren't totally sure when to solve the equation for y equals or solve the equation for x equals. So that's a really, really important thing here. Think about the direction of the rotation, the direction of the dimension of the cross section. This section, the dimension that we're always looking for is a radius. So it's either a horizontal radius or a vertical radius. Okay? So here we have a horizontal radius. We have an x equals. So we take the equation y equals x cubed and solve it for x equals cubed root of y, which is equal to y to the 1/3, however you want to write it. Okay, so that's our radius. So pi r squared, pi can go inside or outside, y to the 1/3 squared dy. Like I was saying before, I always keep my limits of integration as the last step because it can be a reminder. I look at my integral, I look at my formula and say, okay, I've got y's here, so I need to go to the y-axis, lowest to highest value on my graph, 0 until 8. Okay, I take that integral and I put it into the calculator. Okay, we get an answer of 60.3. Doesn't stop. All right. Example 2. My husband is making fun of me because it is 7:30 at night and I'm making my video for you guys so that I can teach my kids in the morning instead of teach you all. I'm going to keep going, ignoring him as much as possible. All right. So, next one. Rotate the region bounded by y is equal to 4 minus x squared. X equals 0, y equals 0. About the y-axis. 4 minus x squared. Parabola opening downward. Vertex is up at 4. X equals and y equals are just the axes. So here is our shaded region. Okay, the left side of that parabola, not super relevant, but because it has symmetry to begin with, our reflection is going to be that exact same space on the left side. Right? So now we have this parabola spinning. Okay. So we have a circle with a horizontal radius, which is x equals. So y equals 4 minus x squared is what we need to solve for x equals. So that's side work. And we have the square root of 4 minus y. Another caution here, some of you tried to simplify this radical on the previous quiz. You can't. It has to stay exactly as is, even though 4 is a perfect square. Even if y was squared underneath of that, you would not be able to simplify it. So anytime there's addition and subtraction inside that radical, do not look to simplify. Just leave it as is. So x equals the square root of 4 minus y. Again, that's the distance from the y-axis over to the curve, which is exactly half of the entire circle, so that's our radius. So we have pi radius squared dy. Bottom to top, 0 to 4. If you weren't positive about that 4, again, graph this in Desmos and you would see where the vertex is at 4. So before I go to Desmos here, I am going to simplify because now I have a square root squared. So I just have 4 minus y dy going into the calculator. Answer of 25.1. Okay, last example for today. Rotate the region bounded by y equals x squared. Parent function parabola. X equals 0, which is the y-axis. Y equals 1, horizontal line, about the y-axis. So, similar to the last two, this is the original, but if we reflect this and rotate this, we do find our symmetry with the exact parabola that we had already sketched. So this rotation is here, like a teacup, right? That's another example. If you go to Great Adventure or any carnival, riding the teacup would look like this. Horizontal radius, x equals, and in this case, x equals root y, or y to the 1/2, however you want to write it. Pi root y squared dy for area of a circle from 0 until 1. So pi y 0 to 1 dy. .57 we'll go with. Okay. All right, so that's it for today. Nice and quick lesson for today. We will take Friday off, right? Friday's a reading day. So I'll post the final video from this section on Monday. We'll cover a little bit more what if we shift our vertical axis of rotation, and we'll see what the washer problems would look like in this section. We'll review the horizontal axis of rotation, and again, you'll have a worksheet day and a quiz day. I believe next Friday is a reading day as well, so that'll bump this section even longer to the following, I don't know, Monday for the quiz or Tuesday for the quiz, because I think we finally hit Memorial Day. Anyways, this is the last section though, you guys, so after this we will have one project, and that'll be it for the year.